here's what it looks like if you can use your screen instead of your calculator and use a standard moment calculator. A spreadsheet worked out, checked. Remember, 1 in the x, 1 in the z gives us -1 about the y-axis, so a -1j for the moment vector. Of course, people are going to have sometimes a hard time doing this, but going ahead and changing the UCS. I like to use 3-point, but I'm just going to use the endpoint there. Be very careful when you're setting up your UCS that you grab the right thing. You have to hit enter to accept. And then that idea of changing the CUI, custom user interface, so that it does pop up so you don't have to necessarily use list. We're going to use the rollover tooltips in this case. For a line, we're just going to be at the start x, start y, delta x. This is again a 2D problem. Be careful when you're using in 3D that you make sure that you grab all the information you want. That's all I want. We're going to hit apply here. Data extraction will work, but you can get you do want to be aware of how approachable and doable this work is. And hit OK here. And so we can just now start going around, taking over the top. That line begins at 3.9506 and 0.9961. Now, I'm not sure how the 3.9506, so I'm clicking here, 3.9506, and I go over to here. That's what it pencils. You're looking at potential transcription errors there, 0.9961. Tabbing back and forth. The force, that was the start, x and y, the delta. Using my tooltips, rolling over, making sure I grab the right line. Minus 9.8. We're realizing there's nothing in the z here. Minus 9.8. Hitting a tab. What you see now that you in fact have one of the moments calculated. You could do the reaction for just that one, or like many programs, you can go across the line here and pull that down, edit, undo, edit, copy, edit, paste formulas only. So if I now hopefully put this, hopefully it will work. So now we go to the next one, 14.8963. 14.8963. Of course, you don't need to keep that kind of level of accuracy when you're transcribing. 4.3771. And in a second you'll see how in fact list might be a better way to go if it will keep that up. It will keep the list up on your screen. 5.1037. This is why I would prefer a calculator. Tab over. Minus 4.3771. Now, one thing I want to point out then is the fact that these numbers here look wrong, and that's only because I left a force in the z from my example there. So this one now here is going to be 0, and in effect we'll see whether we can copy, Control V. It's not letting me in this calculation. So more or less go through, and you can do it on a real basis. You can now try one of the great things about LIST, however, if we do a list on something, we can grab the starting point, starting point there, right click, copy, go over here, Control V, I'll try it here, Control V, so you copy and paste. So that's the great thing about the list. Control V, Control C works. Again, I'm working here in a Google document, but try it again. So I only got to do one this time. If I do LIST, over here, I grab the start X, copy, go over to here, Control V in this program. I can go back to the delta Y in this case, using a Control C, Control V, 0, and we'll just see whether these add up. This isn't the right calculation, but make sure that it's grabbing before you do a lot. Make sure it's grabbing. This is not the correct calculation. This is not the correct calculation. I repeat, this is not the correct calculation. In a second, you want to be able to visualize the determinant in at least up to a 3 by 3, hitting an enter there. So you have to be sometimes wary if it's not taking your format input. So that's one of the problems with cut and paste as well. Sometimes it grabs text, but the general sense there that you can do something like that, A6, B6, depending whether this is text or the like. So great reason to use a calculator, I would show you there, but the sense that you can do stuff like this in Excel and in a Google document if it's set up. I want to definitely show you that this learning to do this when you're laying out a spreadsheet as opposed to Sarah's method otherwise will kind of make sure that you can go across the table here and then get your calculations. This lets you allow you to stack up a whole lot of different variables or a whole lot of moments, if you would. And then of course you just add them up, divide them by the distance between the supports, and that gets you the reaction at the other support. When you go ahead and put all these things in, remember one of the things we looked at is you don't necessarily need to shift your coordinate system. So if you're here, one thing you can do, and it'll be more important maybe perhaps later, you can now change your UCS to the, and these each have an insertion point, to the insertion point there. Now of course if you do each of these, now if I list, once again UCS from the endpoint there, it's not an endpoint I'm doing, and then I have to enter to accept. And then if I do list, it's going to give me the new data, which was just the shift of the distance between the supports. So you can do that just as well as mathematically, though it's going to be easier for some of you to see it, perhaps by shifting it around. This is just vector mathematics. The only difference between the vector to here from the 0, 0 to there is the radial vector, is that the difference vector. So you do some additions and subtractions. All right, so that's how you go about doing it. I recommend learning to do this in a calculator because just the hassle of kind of going back and forth in a spreadsheet. Definitely Excel is a little easier for many of you to use. I would even admit, even for me, though Google Docs is free. So there's something called Open Office that's going to work exactly the same way. So we'll end it up on that one, and just for grins, I'm going to show you, of course, before we finish out, or so we can finish this recording, I'm going to show you in effect what it takes to make the lists file new. All I would need to do now is to turn on my calculator and do 10 store second list options dimension second list L, and I'm going to make alpha R alpha X. You can do that many different ways. I just made a dimension list for the r sub x, the r sub y, the r sub z, r sub n, f sub x, f sub y, f sub z, f sub m, with m being the magnitude of that particular, and then r sub m sub x, m sub y, m sub z, m sub m, with the m being the magnitude, and then doing summing of lists. Easy as that. Thanks for listening.